NEC Article 392 addresses the requirements for cables, cable trays, and cable systems in various applications. When dealing with wire bundles, it's crucial to consider derating factors to ensure safe and compliant electrical installations. Derating factors are applied to reduce the ampacity of conductors when they are bundled together, as heat dissipation becomes more challenging. For conductors in parallel, the derating factors are as follows. Firstly, for 2 to 3 conductors, derate by 80%. Secondly, for 4 to 10 conductors, derate by 70%. Thirdly, for 11 or more conductors, derate by 50%. For conductors not in parallel, if there are 2 or more conductors, derate by 80%. Based on the scenario presented, each bundle contains approximately 12 to 15 cables running for 30 feet in an open-air environment before branching off to various loads. While these bundles might not be classified as being in room air, given that they are not within a room or enclosed space, their placement in a well-ventilated area could facilitate some degree of cooling. Consequently, a conservative approach would involve applying the derating factors for conductors that are not in parallel. This results in a derating factor of 80%, which adjusts the ampacity by multiplying the original ampacity by 0.8. If wire bundles are derated by 80%, the selection of the electrical panel needs to account for this reduction in ampacity. For example, if the bundles were initially intended to carry 100 amps each, the panel should be rated for at least 160 amps, calculated as 100 amps times 2 bundles times 0.8 derating factor. The final decision on the acceptability of the installation lies with the local authority having jurisdiction, or OJ. Although the electrical code may not specifically cover wire bundles in open air, the AHJ might require derating or separation of the bundles to guarantee safe operation. To proactively address any potential issues, several steps can be taken. Firstly, contact the AHJ to discuss the installation details and secure their approval. Secondly, consider dividing the cables within each bundle into smaller groups to minimize derating effects. Thirdly, explore using cables with higher ampacity ratings to offset the impact of derating. To elaborate further on the NEC requirements and the application of derating factors, let's consider specific code sections and practical examples. NEC Article 310.15, Ampacity of Conductors, provides the general guidelines for determining the allowable ampacity of conductors based on their insulation type, size, and installation conditions. It also references tables that list the ampacities for various conductor types in different environments. The specific ampacity tables to consult depend on the conductor's insulation type and temperature rating. For example, Table 310.15b16 lists the allowable ampacities for insulated conductors rated up to 600 volts, not more than 3 current carrying conductors in a raceway cable, or based on ambient temperature. When conductors are bundled together, the heat generated by each conductor can raise the overall temperature of the bundle, reducing the ability of the conductors to dissipate heat effectively. This is why derating factors are applied to compensate for the increased temperature. NEC Article 310.15 Adjustment Factors specifies the adjustment factors that must be applied when the number of current carrying conductors in a raceway or cable exceeds 3. These adjustment factors are based on the number of conductors and their impact on heat dissipation. The adjustment factors in Table 310.15 are used to reduce the allowable ampacity of the conductors to ensure that their temperature rating is not exceeded. In the context of wire bundles, the adjustment factors in Table 310.15 apply when the bundles are considered to be installed in a raceway or cable. However, when the bundles are installed in open air, the AHJ may have discretion in determining whether these adjustment factors apply. If the AHJ determines that the bundles are adequately ventilated and that the temperature rise is minimal, they may allow the use of high ampacities. Conversely, if the AHJ determines that the bundles are not adequately ventilated, they may require the application of the adjustment factors in Table 310.15 or other derating factors. It's important to note that the derating factors specified in NEC Article 392 apply specifically to cable trays and cable systems. While these derating factors may provide some guidance for wire bundles in open air, they are not directly applicable unless the AHJ deems them appropriate. Therefore, it's crucial to consult with the AHJ to determine the specific derating requirements for wire bundles in open air. In addition to the derating factors, other factors can affect the ampacity of conductors, such as ambient temperature, conductor insulation type, and conductor size. Ambient temperature is the temperature of the surrounding environment, and it can affect the ability of conductors to dissipate heat. Higher ambient temperatures reduce the ampacity of conductors, while lower ambient temperatures increase the ampacity. Conductor insulation type also affects the ampacity of conductors. Different insulation types have different temperature ratings, which determine the maximum temperature that the conductor can withstand without degrading. Conductors with higher temperature ratings can carry more current than conductors with lower temperature ratings. Conductor size is another factor that affects the ampacity of conductors. Larger conductors have a greater surface area for heat dissipation, which allows them to carry more current than smaller conductors. The ampacity of a conductor is directly proportional to its cross-sectional area. When selecting conductors for a particular application, it's important to consider all of these factors to ensure that the conductors are adequately sized to carry the expected load current without exceeding their temperature rating. Overloading conductors can lead to overheating, insulation damage, and even fires. Therefore, it's crucial to follow the NEC guidelines and consult with a qualified electrician to ensure that electrical installations are safe and compliant. In the case of wire bundles in open air, it's particularly important to consider the potential for heat buildup and the impact on conductor ampacity. By consulting with the AHJ and following the recommendations outlined above, it's possible to create a safe and reliable electrical installation that meets the requirements of the NEC. Remember, electrical codes and regulations are in place to protect people and property from electrical hazards. Adhering to these codes and consulting with qualified professionals is essential for ensuring the safety of electrical installations. In addition to the NEC, other standards and guidelines may provide further information on wire bundling and derating factors. For example, the Insulated Cable Engineers Association, or ISA, publishes standards for insulated cables, including information on ampacity ratings and derating factors. These standards can be a valuable resource for electrical engineers and contractors. Furthermore, manufacturers' data sheets for cables and conductors often provide detailed information on ampacity ratings and derating factors. These data sheets should be consulted when selecting conductors for a particular application. To summarize, when dealing with wire bundles in electrical installations, it's crucial to consider the following points. Firstly, consult with the local AHJ to determine the specific derating requirements for wire bundles in open air. Secondly, apply the appropriate derating factors to compensate for the reduced heat dissipation caused by bundling. Thirdly, select conductors with adequate ampacity ratings to carry the expected load current without exceeding their temperature rating. Fourthly, consider separating the cables in each bundle into smaller groups to reduce derating effects. Fifthly, use cables with higher ampacity ratings to offset the impact of derating. Sixthly, follow the NEC guidelines and other relevant standards and guidelines. Seventhly, consult with a qualified electrician to ensure that electrical installations are safe and compliant. By following these recommendations, it's possible to create a safe and reliable electrical installation that meets the requirements of the NEC and protects people and property from electrical hazards. Always prioritize safety and consult with qualified professionals when working with electricity. The NEC is updated regularly, so it's important to stay informed about the latest changes and revisions. This will ensure that electrical installations are up to date and compliant with the current code requirements. Continuing education and professional development are essential for electrical engineers and contractors to stay abreast of the latest advancements in electrical technology and safety practices. The electrical industry is constantly evolving, and it's important to keep learning and improving to provide the best possible service to clients and ensure the safety of electrical installations. In addition to the technical aspects of wire bundling and derating factors, It's also important to consider the practical aspects of installation. Wire bundles should be neatly organized and properly supported to prevent strain on the conductors and terminations. Cable ties or other fastening devices can be used to secure the bundles and keep them in place. The bundles should be routed in a way that minimizes the risk of damage or interference from other objects. Adequate clearance should be maintained around the bundles to allow for proper ventilation and access for maintenance. When terminating conductors and wire bundles, it's important to ensure that the connections are properly made and tightened. Loose or corroded connections can cause overheating and electrical failures. Terminal blocks or other connection devices can be used to provide secure and reliable terminations. The terminations should be properly labeled to facilitate troubleshooting and maintenance. Regular inspections and maintenance of electrical installations are essential for identifying and addressing potential problems before they become serious hazards. Inspections should be performed by qualified electricians who are familiar with the NEC requirements and best practices for electrical safety. Maintenance tasks should include checking for loose connections, damaged conductors, and other signs of wear and tear. Any problems that are identified should be promptly corrected to prevent electrical failures and ensure the safety of the installation. In conclusion, wire bundling is a common practice in electrical installations, but it's important to understand the potential impact on conductor ampacity and take appropriate measures to mitigate any risks. By consulting with the AHJ, applying the appropriate derating factors, selecting conductors with adequate ampacity ratings, and following the NEC guidelines and other relevant standards and guidelines, it's possible to create a safe and reliable electrical installation that meets the requirements of the code and protects people and property from electrical hazards. Always prioritize safety and consult with qualified professionals when working with electricity.